Let's say that you are required to solve for x for this equation. You can already tell that the bases are actually not the same. And in order for you to solve for this, we normally push towards making both the bases look the same. But you can see that it will be very impossible for you to do that in this case. What is it that you can do to solve for x in this case? Let me show you a couple of steps that you can apply to solve for x in this equation. The first one, we can take out the common factor from this exponents on the left hand side. So let us write it down. So we have, so this exponent here is 2x plus 6. So we know that this can be rewritten as 2x plus, so 6 is the same as 2 multiplied by 3. So the right hand side, we write it as it is. And then as we continue on the left hand side, so we're going to write our base 5 as it is. And then we have to take out a common factor from 2x plus 2 multiplied by 3. In order for you to take out a common factor from this, you need to look at your sign. You look at what you have before the positive sign and what you have after the positive sign. We have 2 and x before the positive sign. We also have 2 and 3 after the positive sign. What is common here before and after the positive sign? It's 2 and 2, meaning the common factor here will be 2. We take it out and then we open a bracket. And then after this, we go up here again and we say we took out 2 before the positive sign. We are left with x, variable x. We write it down. And then we write down our positive sign. And then after the positive sign, we also took out 2 as a common factor. We are left with what? With 3. We write the right hand side as it is. And then as we continue, what we're going to do on the left hand side is that we are basically going to apply the power of a power whole by taking these 2 within the bracket. So in other words, we are going to write our base 5 and then we only take these 2 within the bracket. So we're going to have 5 to the power of 2 close bracket, and then we write this as it is, which is x plus 3. You must remember that if we apply the power of a power rule here, it will take us back to this. Then we write the right hand side as it is. And then as we continue, we can just find the value of 5 to the power of 2. So we know that 5 to the power of 2 is the same as 5 times 5, which is what? Which is 25. This will be to the power of x plus 3 is equals to 7 to the power of x plus 3. And then as we proceed, we can then divide both sides by either 25 to the power of x plus 3, or we can also divide both sides by 7 to the power of x plus 3. Remember, the goal here is to factor out the common exponent, which is x plus 3. We have x plus 3 on the left and we have x plus 3 on the right as our exponent. Let us just divide both sides by 25 to the power of x plus 3. So we'll have, after dividing both sides by 25 to the power of x plus 3, we know that this and this, when you divide them, they will give you 1 is equals to, so here we are going to apply what we call the power of a fraction whole. So the power of a fraction whole, let's say you have a divided by b to the power of x. It will be the same as having a to the power of x divided by b to the power of x. This is the power of a fraction whole. In this case, we are just going to take 7 divided by 25. And then we just write one exponent. Remember, we have x plus 3 and x plus 3. So we just take it x plus 3. It's because of the power of what? Of a fraction whole. To proceed in solving this, we can then look at what we have on the left hand side and what we have on the right hand side. So you can see that the bases are not the same. But remember that according to the exponential rule, any number, or let me put it like this, any non-zero number to the power of 0 will give you 1. In other words, we can rewrite this with the same base. So we can have base 7 over 25 to the power of 0, because this will give us 1. We can also punch this into calculator. It will definitely give you 1. Remember, we did not change nothing, because if you apply this, it will give you this. It will be equals to, here we will have this as it is, 7 over 25 to the power of x plus 3. Now that we have similar bases, remember we have base 7 over 25 equals to base 7 over 25. We can just equate this to exponents. So we have 0 is equals to x plus 3. Since you're solving for x, we're going to transpose this 3 to the left hand side. In other words, its positive is going to be negative 3 equals to x. So x is equals to negative 3. We can also verify this by inserting the value of x here and here. So both sides must be equal. Thank you. Please don't forget to follow, like, and also subscribe if you're watching from YouTube. Thank you.